Hello everyone, I welcome you all to this new video. For the past couple of videos we have been trying to build a machine learning model in order to predict the solubilities of organic molecules. In the last video we saw we can identify some important descriptors from the dataset using feature importance algorithms on random forest estimator. In this video we will talk about hyperparameter tuning and we will see if that has any impact on the accuracy of our models. So I'm gonna start off by importing important libraries, pandas, numpy, seaborn and all other standard libraries which we have used before. I'm also importing some important modules from sklearn library. Now just to refresh our memories, I am again loading this dataset containing 281 descriptors which we stored in Delaney_Modred_truncated CSV file. So let's go ahead and have a look at our dataset. So this was our dataset. We had the names of the organic compounds, smiles, this was our target measured log of solubilities, and all these 281 were our descriptors. And we went ahead and defined our dependent and independent variable. We also scaled our dataset using standard scaler. Although it's not necessary for random forest or tree based models to scale the dataset, but it's always a good practice to scale using standard scaler or any other technique. So in this line of code I'm just using standard scaler to scale all our descriptors, and I'm storing this in a variable called x. Let's have a look at the shape of x. So we have 1144 data points and 281 descriptors. Now let's just go ahead and split our dataset into training and test set. Like before, I'm using random forest regressor to build a model. First I'm creating an instance of this class, then I'm fitting the data on the training data, and in the end we are going to be looking at the R2 scores of our training set and test sets. So let's go ahead and run this. So using 281 descriptors, we had R2 training score of 9.985 and for test we got 0.867, and we saw that with the reduced number of descriptors we did not see much change. So let's just go ahead and use feature importance algorithm. So all we need is this feature underscore importances underscore attribute on random forest estimator, which would provide us the importance of each descriptor, and then we stored this as a dictionary as a key value pair, features names being the keys and their importance being the value, and then we converted into a data set. And I showed you in the previous video we used just 5 descriptors. In this video we are gonna be using 8 descriptors to build the model. Again, there is no rule of thumb, it totally depends upon you, but since we are gonna be hyperparameter tuning our model and we just don't wanna miss out on anything, so that's why I'm using 8 descriptors this time instead of 5 descriptors. So let me just show you the feature importance chart here. This is the bar plot, and again these are the important descriptors which we discussed above, and in this video we were gonna be using these 3 more descriptors instead of just 5. So in here I'm just grabbing the column names of our top 8 descriptors. So we have the column names, and then based on these column names I am slicing our initial data set. So let's look at the head. So this is gonna be our final data set containing 8 descriptors which will take ahead for building our models. Again, you also want to store this data set in case you need it further. And like before, let's just define our dependent and independent variable, and again I am just scaling this data set using standard scaler. Then we have to split into training and test set. And then again let's just have a look at the scores, R2 scores for our random forest model. Like I already told you, there wasn't really much difference between these less number of descriptors and the one we used with 281. You can see here with 281 descriptors we had accuracy of 0.867 for test, and in here we have around 0.863, so it's pretty same. Okay, now I also wanna show you the results with extra tree regressor. Why I'm using this is because if you remember, in our previous videos, we used this lazy predict to screen more than 40 models for the data set, and we saw that along with random forest, we saw that all these models had high accuracy as well. For example, Bayesian Ridge had 0.91, Elastic Net CV had 0.91, and extra T regressor was pretty much same as well with 0.90. Again, just we don't want to miss out on anything. That's why I'm using extra tree regressor as well. Again, you can go ahead and use these as well, but it does not really matter. It's not gonna impact the accuracy that much. And if you compare it with our random forest regressor we had with random forest 0.86, so there was quite a bit of difference. So that's why I'm also want to check with extra T regressor if there is any difference. So with extra T regressor, again, we are creating an instance of the class and fitting our training data, and then we are gonna be printing the R2 score for training and test set. Okay, so we have got the results. Again, it's pretty similar here, 0.863 and 0.863 for both of these, and we saw a bit of high training score, and that's just due to overfitting, and that's what we are gonna be trying to do with a hyperparameter tuning, that we will try to see if we can reduce this overfitting to some extent. I think accuracy is pretty good, and let's just see what happens when we tune our parameters. So what we are gonna do is we are gonna be using GridSearchCV first to tune the hyperparameter for both of these models. Now I'm at the official documentation of GridSearchCV on sklearn. So GridSearchCV is a class which we need to import from sklearn.model_selection, and we need to provide all these parameters in order to tune our hyperparameters. Estimator is basically the model for which we want to tune. You can use random forest, you can use extra T, or any other model which you want, and we are going to be providing the instance of the class that we created. param_grid, in this we have to provide a dictionary of our parameters basically, and we are going to be seeing that in a minute. Scoring is basically we are doing regression, so we want our R2 scores. Number of jobs is to if you want to run in parallel, if you have multiple cores. CV, so this is highly important. We are gonna be comparing these cross validation scores here. So what we are gonna do is we are gonna provide the argument as 3 in here, or you can do 5 as well for 5-fold cross validation. But since it takes a lot of time, so I'm gonna be using 3-fold cross validation, and we are gonna be comparing the mean of this on all our iterations. Verbose is 0 here. If you don't want to see the progress, you can put 1 or 2 or 3, and it will provide you the progress of how the algorithm is going. So these are the kind of important parameters which we need to put in. We are back at the Google Colab notebook. So what I'm going to do is I'm going to be importing GridSearchCV from sklearn.model_selection. Now this was the default parameters which we used while building our model in here or even above. And now since we have been talking about random forest regressor, just in order to understand these parameters better, I'm gonna give you a brief outline of how random forest regressor works. So this is our data set, right, with all these 8 descriptors, and this is training data, which is 80% of our data set. Now what happens in random forest regressor is that we have plenty of base models. Default value is 100, so we have 100 base models and we call them decision trees. Okay, now what happens is that we are gonna do row sampling and feature sampling. Basically we are gonna be grabbing some part of the data set, some rows and some columns, and we are gonna be feeding it to one decision tree. And then again we are gonna be doing row sampling and feature sampling with replacement. That means there is a possibility of overlapping of data points as well, and we are gonna be feeding it to another decision tree, and again we are gonna be grabbing some other parts of the data set and we are gonna be feeding it to our third decision tree, and so on until we have used all of our data set. Now all these decision trees have been trained on a different subset of data, right? So they are kind of expert in their own domain. Now the question is how the prediction would occur. Now let us just say we have trained our model and we want to predict the solubility of some random molecule with this smile string. So what would happen is that since each decision tree is different, trained on a different subset of data, each decision tree is gonna give a different value. Let's say this gives a solubility prediction of 2.5, this gives 2.1, this gives 2, and so on. Now what we are gonna do is we are just gonna take the mean of all of it, and that would be the predicted solubility value of this particular organic compound. So coming back to our notebook, so these are the default values of the parameters, and for hyperparameter tuning we are using this GridSearchCV class, and like I told you, we need to put in the estimator, which is random forest, and all the parameters as a dictionary. Basically we have the parameter name as key and their values as a list as values. So in here the default value is 100 for n estimators, and n estimator basically means the number of decision trees, and we want to screen all these values here. Bootstrapping is true, and we want to use both true and false. And bootstrapping is basically, like I showed you, we are using row sampling and feature sampling, and we are feeding it to all these decision trees. So that is basically bootstrapping. Maximum depth parameter controls the maximum depth of each decision tree in the forest. Now decision trees can capture more complex patterns in the data, but they can also increase the risk of overfitting. So what we are going to do is we're going to screen these values for our model, and we are going to be seeing what works best for us. Maximum features, this parameter represents the maximum number of features considered for splitting a node, and it can have significant impact on the randomness of each tree. And we want to screen log 2 times the maximum features and square root of the maximum features for splitting the node. Minimum sample leaf is the minimum number of samples required to be at the leaf node. This parameter helps control overfitting by setting a threshold for the minimum number of samples. So we are going to be screening just 2 and 4. Again, you can go ahead and use as many values as you want, but again that's going to take you a long time. So we are just sticking to these 2 values right now. Minimum sample split is the minimum number of samples required to split an internal node, and we are going to be using 5 and 10. Now cross validation score is 3 here, so we want to cross validate 3 times. Again, you can use 5 or 10, but again that's going to take a long time. I don't want to print any output, and scoring function is R2. So first let's just create an instance of this. Although we don't need to, we have already done it here, but just for the sake of this tutorial I am running this again, and we are gonna be running the GridSearchCV. So let's just run it, and so we have created an instance of this class. So now what we are gonna do is we are gonna be fitting our training data in here. Now this is gonna take some time. So in order to see how much time it takes, I'm gonna be using this time module. I'm starting before and I'm gonna be ending after it runs, and then we are gonna be printing the time here. So let's run this and see how much time it takes. So it has finished running the code, and it has taken us around 2094 seconds, so around 35 minutes. So it has taken us a lot of time. Now we can visualize the results using CV underscore results underscore attribute, and if we just run it, we can see there is a lot of information in here. And just in order to visualize it more appropriately, I'm converting this into a data frame, and all we care about is the mean cross validation scores, and we just want to pick the best mean cross validation score. So what I've done is I have so let me just first show you how our data set looks like. So this is our data set, basically 480 iterations, and we have 17 columns here. Now as you can see, there is a lot of information here: mean fit time, standard fit time, whether bootstrap is true or false, maximum depth, maximum feature, and all that stuff. So what I'm gonna do is I'm gonna sort this data set based on this mean score, and we are going to be looking at the first 5 data points, although we just need the top ones. So this contains the hyperparameter information which gave us the maximum cross validation score, and that is 0.876, and it has ranked 1. And if we look at the parameters, number of n estimators are 800, minimum sample split 5, minimum sample leaf 2, depth 45, bootstrap 2. So what we don't really need this, we can just run a best underscore params underscore attribute in order to get the best parameters. So these are best parameters where bootstrap is 2, maximum depth is 45, maximum features which we have chosen is log 2 of the maximum features, minimum sample leaf 2, and minimum sample split 5, and number of n estimators 800. And it is the same as our first point over here. Now I'm just gonna real quick put all that arguments in here, and then we are gonna be checking the R2 scores of our training and test set again. So I have put all that information in here, and I'm gonna be running it now. The test score is pretty much same with the value of 0.858, and initially we had a value of 0.861, so there isn't much difference, but the train score has come down from 0.982 to 0.965. So that's a good thing because we have reduced the overfitting in here. And what we are gonna do is we are gonna be doing the same for extra T regressor. So initially I'm just creating an instance of this extra T class with all these default parameters. So let's run this, and using GridSearchCV I am just using the same parameters which we have used for random forest. So let's run this, and again we are gonna be fitting our training data on this instance, and it will calculate the cross validation scores for all the permutations and combinations. So let's run this, and when it's done I'll get back to you. So it has finished running GridSearchCV for extra T regressor, and it has taken us around 20 minutes. So let's just go ahead and have a look at our best parameters. So these are the best parameters that we have for extra T. So let's just go ahead and create a model using all these parameters. So what I'm gonna do is I'm gonna feed all these arguments in here, and then we are gonna be creating an instance of this extra T regressor class again. So I have put in all this information in here. So let's create an instance of this class, and then we are gonna be calling a fit method to train our data. And in the end, we are gonna be printing our R2 score for training as well as test set. So in here, if we look at the test scores, it has come down just a little bit from 0.865 to 0.851. And the train score has also come down from 0.999 to 0.953, and that's again a good thing because we don't want our model to overfit a lot, and it has reduced the overfitting to some extent. Again, this is not perfect. You can go ahead and screen more hyperparameters and see if that impacts our training score. But I think still we have good results both for extra tree as well as random forest regressor. And since the test score of random forest is just a little bit more than extra tree, so I think we are gonna be sticking with random forest as our final model for now. Now just one last thing I want to talk about is, as you can see here, this GridSearchCV takes a long time to run. Just in case you want to avoid all that computation, what you can do is you can use RandomizedSearchCV. So what I'm doing here is I'm importing RandomizedSearchCV class from sklearn.model_selection. The procedure is pretty much similar. We need to create an instance of this class with our estimator, which in this case is random forest. Then we need to put in all these parameters and the values that we want to screen in the form of a dictionary as key value pairs like we have seen before, and these values are the same as we have used before. So what I'm gonna do is I'm just gonna run this, and the only difference in here is that we need to put in one more parameter of n underscore iter. So if the value is 10, it will just randomly select 10 permutations and combinations instead of running all the permutations. And if you select 20, there will be 20 different combinations which would be screened, and the best out of them would be displayed using best underscore param underscore attribute. So let's just run this. Rest everything is same. Scoring is R2, cross validation is 3. So we have created an instance of this class, and then again we are gonna be fitting our training data, and it'll probably won't take us much time. So it has finished running the code, and it has taken us just 30 seconds as compared to before where it took us around 35 minutes. So this is pretty good. If you just wanna quickly screen your hyperparameters, you can just use this randomized search CV. And now we are gonna be looking at our best parameters out of these 10 iterations. So these are the best parameters that we have. Now what I'm gonna do is I'm just gonna feed these arguments in here, and then again we are gonna be seeing our results using these parameters. So these are the results we have, and you can see this is the comparison on the right side with the default parameters, and I think it's pretty much the same. So we haven't really seen any decrease in overfitting or increase in our predictive power. So one thing we can do is we can just run this again here, and it will pick up different combinations of these parameters. So it has finished running, and let's just have a look at our best parameters again. So now you can see these parameters have changed, and we can again put that in here. Now we can see there is just a slight change again. So I think you have got the idea that if you want to quickly run your screening, you can use randomized search CV. But GridSearchCV would provide you a more thorough screening, and of course we have seen better results with that, and that's what we are going to be sticking to, using all these parameters with test score of around 0.858 and train score of 0.965. So I'm gonna end this talk right here. In the next video we are gonna be talking about very important aspect of our journey into machine learning, where we are going to be compiling all our results, and we are going to be writing that in a manuscript format. If you're a graduate student or a project student, communicating your results is one of the most important things, and no matter how good the code is or how good you are at coding, if you are not able to communicate properly your results, your skills are gonna be not that rewarding. So stay tuned for the next videos. Make sure you are subscribed to the channel, and thank you for watching.